Hello guys, I'm Dipali Chandel and I welcome you all over here to the word embeddings tutorial. So in the last tutorial, I discussed about count vectorizer. So what are the limitations of count vectorizer? As we can see in the result over here, we have lot of zeros. Okay, so this is a sparse matrix. When we get lot of zeros, then that matrix will become a sparse matrix. Okay, now, if we can say if our documents are small, then it is fine. But if our documents are large enough, then what will happen? This will consume lot of memory and processing speed will also decrease. So this problem or limitation of count vectorizer is overcome by the hashing vectorizer. Now, the next limitation of the count vectorizer is the most frequent words in the count vectorizer will have high frequency as compared to the other words. Okay, so what will happen? All the algorithms will learn, the algorithm that we're gonna use will learn all patterns from those high frequency words, or we can say most frequent words. So it will suppress the effect of the less frequent words. Now, this problem will be overcome by the TF-IDF vectorizer. Fine. Now let's start with the hashing vectorizer. So in this tutorial, we're going to discuss about hashing vectorizer and TF-IDF vectorizer. Now what is hashing? Now just understand, let me give you one example. Okay, suppose this is my table of content of a book. Okay, over there I get the serial number and then chapter name and then page number. Okay, so what is the serial number? 1, 2, 3, 4, 5, and these are my chapter names corresponding to those serial numbers. After that, the corresponding to those serial numbers and chapter names, I have the page numbers at which those chapters are present. Fine, from which from those page numbers my chapters are starting. Okay, so let's say 3, then from chapter number 2 is starting from the page number 10, and let's say chapter number 3 starting from the page number 17 or 18 or 19, let's say 19, and chapter number 4 is starting from, we can take anything, 22, and chapter number 5 is starting from 27. Now what is this over here? See, this is known as hashing. So the concept here running is this chapter 1. Okay, this chapter 1 is starting from the page number 3. This chapter 2 is starting from the page number 10, and this chapter 3 is starting from the page number 19. So this concept is known as hashing in the computer science. Now over here in hashing vectorizer, what happens? Suppose okay, let's look at this example. I have this complete string 1 cent comma 2 cents comma old cent comma new cent colon all about money. Fine. Now see, instead of page number over there we will get the frequency. Okay, so for according first of all, this hashing vectorizer will arrange all the words in the alphabetical order. So, and it will give them index, like there we had the serial numbers, right? 1, 2, 3, 4, 5 for the chapter names. Similarly here we will have the index values. So the index value for the first word, which will be according to alphabetical order, which will be about, right? So the index value for it will be 0. Then for all it will be 1. Then coming to the, we can see it will be cent. So for it it will be 2. Then cents, for it it will be 3. Then after that, um, yeah, money. So it will have 4. Then new, it will have 5. And then old, yeah, old, it will have 6. And then 1, it will have 7, and 2 will have 8. Now see, these words are represented by the index values, and this doc will contain the frequencies. So how many times all is coming? Just one time in the complete document. Okay, so it will give you the frequency. Now how many times this about is coming? Okay, first was about, right? Sorry for that issue. Okay, so first was about. So how many times about is coming? the index value for the about is 0. How many times about is coming in this document? Just once. Okay, so this is for about. Fine. Now for the all, what is the index value for all? 1. Now how many times all word is coming in the document? Just once. Now what is the index value of sent? 2. So this indicates sent, then this indicate we can see sends, and this indicate money, and this indicate new, and this indicate old, and then this indicate 1, and then this indicate 2. Fine. So how many times sent is coming? As we can see, over here, and over here, 3 times, right? So over there we can see 3. Now how many time sends is coming? Just once. This one. Okay, 1. Now how many time money is coming? Once. How many time new is coming? 1. How many times old is coming? Once. Okay, then similarly for the word 1 and 2 as well. So this process is known as hashing vectorizer. Okay, now let's see the code for it. How we will implement it in the coding. Okay, now see. So first I will do the imports. I will do all the imports. After that, this is my complete document which contain these sentences. Fine. Okay, and these sentences are in the form of list, as we can see over here. Now over there I'm using the hashing vectorizer function. Okay, and I'm creating the object for it with the name h vectorizer. Fine. In this, for this parameter, I'm passing the number 10,000. That means number of features I want 10,000. Normalization none. Then alternate sign false. These are some parameters that we have to keep it like this. After that, just I'm doing fitting the transform. Okay, with the help of fit transform function, with the help of this class object. Okay, and in that I'm passing this list which contain these sentences. Okay, now after that we can see what is the shape of that this object that we created. Okay, so 5 rows and 10,000 columns, because we passed n features equal to 10,000, and we can see there are how many sentences are there? 5 sentences. So shape is coming 5 comma 10,000, 5 documents and 10,000 column. Okay, in the matrix. Now let's print this x that we got over here. Okay, so after printing you can see you're getting like we can say hashing kind of scenario that I explained with the help of table of content of a book. Okay, so at the in the 0th row and 93rd column, the word which is there which has the frequency 3. Now at the 0th row and 689th column, the word which is there which has the frequency 1. Similarly, for all the words which are stored at these location will have these frequencies. Fine. I hope this much is clear to you. Now, as you can see, the 0 means first row. Okay, hold on. The 0 means first row. That means first sentence. What was our first sentence? This one. Okay, and 1 means over here you can see this one. So this 1 means second sentence. Okay, so this is our second sentence, or we can say second row. Now then we had the 2, 3 and 4. Okay, so it is hash hash, that means like 2, for it is not showing the completely. Fine. Now for the we can say fourth row which has the index 3. Okay, I'm talking about this one. Okay, so frequencies for the all the words of that sentence are these. Okay, and those words are stored at these locations. Fine. Now similarly for the for all the words which are there in the fifth sentence, the frequencies are these corresponding at the right hand side, as you can see. Fine. So this is known as hashing. Now further moving forward, I want to see for the first row. Okay, so I will write this is complete my x. Okay, now I want to see the first row, so I will write x0 as you can see over here. So it will give me frequency of all the words which are there in the first row. That means all the words which are there in the first sentence that we passed. Okay, this one. Fine. Now I hope this much was clear to you. Now see, after this we're going to understand about term frequency and inverse document frequency, which is known as TF-IDF. Now what is TF-IDF? So it is a statistical measure that evaluates how relevant a word is to a document in a collection of documents. Okay, and it works proportionally to the number of times a word appears in a document, but that that offset by the number of documents that contain that word. Fine, now let's understand that further. So over here we will see this formula. So what does this indicate? Okay, this will give you the TF-IDF frequency, okay, of the word X in the complete document. Okay, and this will okay, so this is term frequency of the, we can say, of a term or of a word in a particular document. Okay, and this is my term frequency, and this is my inverse document frequency, and this is known as natural log. So this is in we can say this is total number of documents, that means, or you can say total number of sentences that we have passed. Okay, and this is in how many documents or how many sentences that word is present. Okay, when I will give you more further, I will explain you the example, then you will get more clear picture about it. Fine, how does this work mathematically? Okay, so let's see this example over here. Now let's say we have 100-word blog post, okay, and that contain the JavaScript word 5 times. Now what is the term frequency for the word JavaScript? 5 by 100, because we have 100 words in total. Okay, now what is the IDF for that? So now suppose we have 10,000 documents, okay, and the JavaScript word is coming in at least 100 of those documents. Okay, so what was the IDF? Log, natural log of total number of documents divided by the number of documents in which that word or term is coming. Okay, so here it will be 1000 divided by 10,000 divided by 100. Now it will give you 2. Fine. So what is the TF-IDF frequency that we will get? Over there we got a term frequency 5 divided by 100, 0.05. Okay, because 5 times the, we can say, the JavaScript word was coming in the complete block, which contain how many words? 100 words. Okay, now over there IDF for that we got 2. So what is TF-IDF? 0.05 multiplied by 2, that is 0.1. But practically, see what happens in this formula. This can become 0. Okay, this might can become 0. That means this might happen like in any of the document that particular word is not present. So in that case, that dfx will become 0. So to avoid this, we will add 1 over here in the denominator. Now, according to the mathematical rule, we have to add 1 in the numerator as well to make it equivalent, right? Fine. Now, now this complete also can become 0. To avoid this, now if it becomes 0, then this, we can say, this complete TF-IDF frequency will become 0. That means that word will not make any impact. Okay, that means that algorithm will not learn anything from that word. To avoid this, what we do over here, we add just 1, okay, along with it. So what 3 changes we did? First, we added 1 in the denominator to overcome the problem of denominator becoming 0. Then to according to go according to the mathematical rules, we added 1 in the numerator as well. Now this complete log can also become 0, and this can suppress the effect of a particular word. To avoid that, we added 1 over here as well, this one. Fine. Now this is the practical formula that is being used in this TF-IDF model. Okay, I hope this much was clear to you. So let's move forward. Now first I will do the imports. These are basic imports. Then in the list format I write my documents. So this is my first one, then this is second one, and this is third one. Okay, after that I will create the object of the TF-IDF Vectorizer class or function. So this is Vectorizer object that I created. With the help of that Vectorizer object, I will use the fit transform function, and in that fit transform function I will pass this text, that complete we can say that list which contain all my documents. Now after I want to see the output of this one, okay, after fitting the transform, that means output of the TF-IDF Vectorizer. So this is the output of my TF-IDF Vectorizer. So in the hashing, the same way it is happening. So what is this? At the 0th row and 9th column, 0th row and 9th column, the TF-IDF frequency for that word which is stored at 0th row and 9th column is this one. Similarly, for the word which is stored at 0th row and 14th column, the TF-IDF frequency is this one. Okay, similarly we can get for all the words. Now let's see the feature names. Okay, that means we want to see all the words that that our TF-IDF Vectorizer learned from this complete these documents. Okay, so we can get all the words with the help of get features name function, and these are those words. Fine. Now I want to see that into the data frame format. So in the data frame function, I will just after converting this X to the array format, I'm passing it into the data frame function. Then in the columns parameter, I'm passing vectorizer dot get features name, because that will give the names to my columns. Okay, these will become my column names. These all will become my column names. Now in the index parameter, how many documents we have? We have 3 documents. So that's why I gave 3 names in the index parameter in the list format: D1, D2 and D3. Fine. Now what is okay, so first we are accessing the shape of X. So what is the shape of X? X was what is X? What is X? X is this one, as you can see. Okay, output of the fit transform from the vectorizer. So what is the shape of it? 3 rows and 18 columns. Now what is the output of the data frame function? This is the output. This is the data frame that we got. So as you can see over here, what is the maximum TF-IDF frequency that you can see from here? As we see, I guess this one. Yeah. So in the document one, in the sentence one, the M word has the highest TF-IDF frequency. Well, let's see that. Since M is coming twice, as you can see over here in the first sentence. Okay. In the first sentence, I'm talking about this one, first document. Okay, I hope this was clear to you. Now let's see the next example as well over here to understand this. Now, yeah, before going to the next example, let's understand how we can how we will get that IDF. Yeah, let's see the inverse document frequency. Okay, so if you want to see the inverse document frequency, I'm talking about this term. Okay, this one. I'm talking about this one. So how we can see what are the values of the inverse document frequency? Simply you have to write the object of the class, okay, object of that function with the help of which we created the TF-IDF vectorizer. Okay, then after that you can use this one, IDF underscore. So it will give you all the inverse document frequencies. Now how it came? See, I told you a formula, if you remember. For practical implementation, we use over there we added 1 in the denominator. Then to make it mathematically correct, we added 1 in the numerator as well. And to avoid that log can also become 0, right? Then that will suppress the effect of that word for which that log is becoming 0. Now we added 1 as well along with it to overcome that suppression effect for that word. Okay, so now with the help of that formula, I want to see for this AI. Okay, what is the index value of AI? 0. Okay, what is the index value of AI? 0. Now for AI, what is my IDF? This is my IDF for the AI. This is my index value of AI. And what is my IDF for the this AI? This is my IDF. Now how it came? So basically simple. How many, first of all, it will be how many documents we have? Total 3 documents. Okay, so number of documents plus 1. So 3 plus 1, fine. Now in how many documents AI is present? Let's see that above. We can see AI is present just in one document over here. So 1 plus 1, 2. So it will become 4 by 2. Okay, this complete term will become 4 by 2. Now again we will add 1 over here as well. Okay, so what we got? 1.69314 something, and that is exactly same over here. Fine. Like this we calculate the inverse document frequency. Okay, now I hope this mathematical explanation of how to create the how to calculate the inverse document frequency was clear, and how to use TF-IDF Vectorizer is also clear to you. Fine. Now one more example is there for it. So this is that example. First we will do the imports. Okay, after that these all are my documents. There are 4 documents as we can see over here. Now I created the object, and then with the help of fit transform function, I passed this complete corpus which contain all my documents into this fit transform function with the help of the object vectorizer, which is the object of my TF-IDF Vectorizer. Okay, now I'm printing this X, so it is giving me this output. Okay, all the TF-IDF frequencies corresponding to all the words. Okay, so this is TF-IDF frequency for uh, words of the first document. This is TF-IDF frequency for words of the second document. Similarly, this is for words of the third document, and this is for words of the fourth document. Okay, now let's see the features. That means all the words, unique words that we want to see. So I'm writing get feature names. I'm using the function get feature names. I'm calling this function with the help of the uh, object vectorizer. So I got all my features. Okay, all my unique words. It will give me all my unique words. Now we want to see the shape as well. So okay, you can see like how many rows we have? 4 rows and 9 columns. Okay, why 9 columns? These are 9 features. Now I want to see that into the data frame format. So in the data frame function, I'm passing X. First I'm converting it to the array, then I'm passing it inside it. Then in the columns parameter, I'm passing these feature names that I will get over here. Okay, so these will become my column names. And in the index parameter, I'm passing how many documents we have? 4 sentences we have. So the names of those will be D1, D2, D3, D4. Fine. So it will give me this data frame. Now, according to this, what is the highest frequency? What is highest TF-IDF frequency in the complete data frame? This one, 0.68764. That means this document is coming at the maximum time in the complete, we can say complete all the documents. Okay, that means this is the most important. This word is the most important. Fine. So guys, now next we're gonna understand about shortcomings of the TF-IDFs. Okay, see, first shortcoming is TF-IDF is still a still a bag of word model. Okay, and therefore it does not count the positioning of words in the document. Okay, let's take the example. Suppose I have two documents, document 1, Bob is clever, then Alice. Second document, Alice is clever, then Bob. Okay, now both have the same set. And what is that set that we will get over here? Bob, then is, then clever, then Alice, sorry, then, and then Alice. Okay, since we have the same set of words with same frequencies, but they are not, but they're all, but these sentences or these documents have the different meaning over here. Over here, Bob is more clever than Alice, and over here in this document, Alice is more clever than the Bob. Okay, so this is the shortcoming of the TF-IDF, that it doesn't for this it doesn't work on the, we can say, context, how that word is being used, or we can say positioning of the words. It it does not count the positioning of the words in the document. Fine. Now another shortcoming is, see, again it will also generate the sparse matrix that will contain a lot of zeros. And why? Why? Simple, like that one. Okay, over there, let's see. See, we are getting 0 0 0 0 0 0 like this. Okay, so it is also generating the sparse matrix, and due to this, its processing speed will decrease and it will consume lot of memory. Now, this shortcoming of TF-IDF can be overcome if we use uh, hashing vectorizer along with it. Okay. So in this tutorial, we cover hashing vectorizer and TF-IDF and the limitations of the TF-IDF, as well as what were the limitations of the count vectorizer. So we'll meet in the next class, guys. I hope this tutorial was clear to you. Thank you very much.